Alright, welcome Algebra 2 class. This is Mr. Adriano, Mr. AC, keeping it fresh, you already know. Today I want to talk about why we use function notation. Now, I noticed on the quiz a lot of you had this mixed up a little bit, so hopefully in this video we'll kind of get an idea of why we use function notation. So, if you notice, usually you get a problem that looks like this. Y equals 4x, let's say 4x plus 3. Okay, now over here on this column, I'm going to write f of x equals 4x plus 3. Alright, keep in mind that this is the exact same thing. Y equals 4x plus 3 is f of x equals 4x plus 3. F of x is just a new way of writing y. So usually when you see a problem in the past, you would have got something like solve for x equals 3, solve for x equals 2. Alright, so now if we go ahead and try to solve that using the method that you guys have known for a while now, we're going to plug in 3 for x because it tells us x equals 3, so we plug that in for x, so we're going to get 4 times 3 plus 3. Well, this is just going to be y equals 4 times 3 is 12 plus 3 is 15. Okay, so we get this answer. Okay, and now we need to solve for when x equals 2. Well, it's the same thing. We're going to plug in 2 for x. So we're going to get y equals 4 times 2 plus 3. Right? So what we get here, if we decide to do that, okay, is we get y equals 4 times 2 is 8, then plus 3 is 8, 9, 10, 11. So we're going to get 11. So y equals 11, y equals 15. Okay, so if you notice here, when I get my answer is y equals 15 and my answer is y equals 11. Now, the reason why we use function notation, and it's a very subtle difference, it's very, very tiny, but it can get kind of confusing when we're not sure why and how to use it, is in this case here, when I look at the answers y equals 15 and I look at y equals 11, I have to kind of look and see where is my work. So for example, y equals 15, well, I know for a fact that came from the upper one because we plugged in 3 for x, and then here we had to plug in 2. Right now, looking at these solutions here, I kind of have to look and see, okay, which one is the correct solution for what. When we use function notation, it's very, very, very subtle, but we can see what number we're plugging in, and we also see the y value we solve for. So f of x is our y value. So when we want to solve, so in this case here, if I tell you solve for f of 3 and f of 2, well, if you look here, 3, if you look at our f of x function notation, f of x, instead of an x here, I'm putting a 3, which means this is what we're going to plug in for x. This is our input. So if we go ahead and start solving this, we're going to get f of 3 equals, this is what we're going to plug in into our x function. Into our function up here. We're going to plug in 3 wherever we see the x. So it's 4 times 3 plus 3. Okay, so f of 3 equals 4 times 3, which is 12, plus 3, well, that's just 15. Okay, so this is one answer. And now we do it with the other one. F of 2 equals 4 times 2 plus 3. All right, so now we're going to get, I'll write it over here. F of 2 equals, well, 4 times 2 is 8, 9, 10, 11, 12. There we go. So now if you look here at my answers over to the right, when I look at my answer right here, I can see f of 3. So when my x value was 3, my y value is 15. So if you see in function notation, right now that we solved it, it's identical to exactly what we just did over in this section here, in this section right over here, except over here, I don't know which one we plugged in 3 or 2 into. Here I just have y equals 15, and here I have y equals 11. Over here, under function notation, I know I plugged in 3 and I got 15. I know here I plugged in 2 and I got 12. So when we use function notation, essentially it lets us know what number we plugged in and then what number did we get when we solved for it. So that's the reason why we use function notation, because later on in class you're going to be solving a lot of problems and I'll be able to recognize right away that when you plugged in 3 you got 15, whereas if we look over to the left here, I have to look and see which number did you plug in. It's a little bit harder to try to navigate. Okay, here, let me see, y equals 4 times 3 plus 3. So I'm assuming that this bottom one is the solution for that, y equals 15. So imagine if you have 5 problems like this and I ask you to solve 5 different problems, being able to see what number you plugged in for your x value, which is the number that's in your parentheses, and then what number you got out, is really convenient. It literally, all it is convenience, and this is why we use function notation. It's for convenience and to be able to determine what numbers we plugged in for x and then what numbers we get out when we eventually solve. So I hope that clarifies as to why we use function notation.